Assalamualaikum, I'm Balkis. For this project, I did the normal distribution, Kruskal-Wallis test, manual calculations, and also data sorting.
Hi everyone, my name is Mohammad Iznulhakimi. For this case study, I was responsible for the normal distribution analysis, the chi-square test of independence, the Kruskal-Wallis test, as well as sorting and preparing the data for analysis.
Hello everyone, I'm Zarif Bukhari Nekman, and for my part, I did the confidence interval in question 2, data sorting and preparing our slide presentation in order our analysis is presented clearly.
Hi and Assalamualaikum everyone. My name is Sofia Binti Sani. In this group assignment, I contributed by conducting the hypothesis testing with related samples and the manual written test. I also assisted in preparing the slide presentation and worked on the data sorting to make sure the data analysis was organized and accurate.
Hi, my name is Zubaidah with Zamri, and today I'll be presenting the part of our project which is analysis of variance question 3D. The second human with me, you test question 4.
Assalamualaikum and hi everyone. My name is Nabil Imran bin Redzuan, and for this project, I contributed for confidence interval, t-test and data sorting.
Hi, it's me again, Siti. So today, our group will be presenting the analysis we've done for the case study. The main goal of this study is to help the LRT management understand what affects passenger satisfaction. We were given a dataset and we used different statistical tests to explore which factors influence how passengers rate their experience.
Let's start with the first question where we explain on normal distribution. There are 3 parts in this question including normal probability plot, hypothesis testing, and probability of sample mean.
Now for question 1A, the age of LRT passengers is assumed to be normally distributed with a mean of 26.9 years. To test this, we constructed a normal probability plot based on our survey data. The plot shows a positively skewed distribution where most passengers are younger and a few older individuals stretch the right tail of the curve. This makes the data asymmetrical, with the mean age higher than the median and mode. These older passengers, though fewer, have a noticeable impact on the overall age distribution, pulling the average age upward. So, while the company assumes normal distribution, our findings suggest the data is not perfectly normal due to the influence of these outliers.
For questions 1B, we choose the manual Whitney test, a non-parametric test, as our data is not normally distributed as discussed before. We use two-tailed tests because we want to see whether the median age of respondents differ by gender. Firstly, we computed sum of ranks for each sample using Excel function rank.avg and sum. After that, we calculated the U stats and Z stats using the formula shown here. And lastly, we decided to reject the null hypothesis, which is where the median is same for the both gender, as the z-stats is smaller than the critical value at negative 1.96 and the p-value is smaller than alpha at 0.05. For the next questions, we want to find the probability. So using the z-table, we found that the probability for respondents who are older than 26 years old is 55.33% and respondents between 23 and 25 years old is 10.79%.
Now, let's take a look at question 2, where we focus on confidence interval. There are 2 parts for this question, which are 90% confidence interval in proportion and 95% confidence interval in mean. For question 2A, we need to construct a 90% confidence interval for the difference in proportion of passengers who are satisfied around 4 and 5 with the 2 measured items under facility quality FQ. First and foremost, we need to select our variables. Based on here, we selected FQ2, which is the perception on disabled friendly features, and FQ3, perception on proper conditions and maintenance of elevators or escalators. Based on the results, we calculate the proportion by dividing sample size with the population. Based on the result, we can interpret that we are 90% confident that the true percentage of the difference in the proportion is of satisfied passengers between the disabled friendly features and proper conditions and maintenance is between 6.07% and 25.36%. Hence, there is significant difference in the passenger satisfaction between the 2 facility quality item at 90% confidence level because 0 is not included in the interval.
Alright, now let's move on to question 2B. For question 2B, we wanted to find out if female passengers are more satisfied with the LRT service compared to male passengers. To test this, we used a 2-sample t-test assuming unequal variances because the number of male and female respondents is different, and so are their variances. So here what we tested. The first one is null hypothesis. Null hypothesis says that female satisfaction is less than or equal to male satisfaction. And the second one is alternative hypothesis. while alternative hypotheses say that female satisfaction is greater than male satisfaction. So from our data, the average satisfaction score for female is 3.4667 and for males is 3.3833. At first glance, it seems like female are slightly more satisfied, but when we look at the results from the T statistic is 0.6969 and the critical value at 5% at 1 till is 1.6596. Since the statistic is smaller than the critical value and the p-value is 0.2437, which is more than 0.05, we fail to reject the null hypothesis. So even though the average for females is a bit higher, statistically, there is no strong evidence to say that female passengers are significantly more satisfied than male passengers.
Moving on to question 3, where we focus on parametric tests, mainly hypothesis testing with related samples and the analysis of variance.
For question 3a, we use a paired sample t-test to compare satisfaction scores between FU2 and FU3. These two features are under the same facility quality dimension, rated by the same 140 respondents. Since the data is related and continuous, this test helps us check if the mean scores differ significantly. For the output, using Excel, we calculated the different scores, mean and standard deviation, and then we found the t-statistic is 4.013, the critical value was 1.977. Since 4.013 is greater than 1.977, we reject the null hypothesis, meaning there is a significant difference in satisfaction. This is also shown in the rejection region of our two-tailed graph.
So for question 3b, for this part, we use a one-way ANOVA test to see if people's perception of timeliness, PS2, depends on how often they use the LRT. The groups we compared were based on travel frequency, most days 1 to 5 times per week, 1 to 5 times per month, and less than once per month. We wanted to know, do people who travel more often rate timeliness differently? So for the hypothesis, null hypothesis, all the groups rate timeliness about the same. For the alternative hypothesis, at least one group gives a different rating. We use a standard significance level of 0.05 to test this. After calculating the average scores, we found people who travel 1 to 5 times a month gave the highest average rating, 3.36, while those who travel less than once a month gave the lowest, which is 2.90. The grand average across all groups was 3.18. The ANOVA test gave us an F value of 3.7 and a P value of 0.256. Since that P value is more than 0.05, the result is not significant. So we do not reject the null hypothesis. As you can see, this graph helps us understand the result visually. The blue shaded line is our observed T value, which is 0.697, and the red zones are where we would reject the null. Since our T value falls outside the rejection zone, we do not reject the null hypothesis. This supports our earlier conclusion, where travel frequency doesn't seem to affect how timely passengers feel the LRT is.
Finally, for question 4, we will discuss about non-parametric tests. We will explain 3 tests, which includes chi-square test of independence, Manu-Winnie test, and Kruskal-Wallis test.
Now, for question 4, we will look at chi-square test of independence. This test is used to determine if there is a significant relationship between two categorical variables. For our analysis, we wanted to find out if there is any connection between employment status and how often people use the LRT. We based our analysis on the following hypothesis, which is H0 or null hypothesis. There is no relationship between employment status and travel frequency, while H1 or alternative hypothesis, there is a relationship between employment status and travel frequency. So to complete this test, there are 3 steps involved. This will be explained by Iznul.
Now for step 1, we'll see on how to calculate expected frequencies in a contingency table by using observed data on travel frequency and employment status. Here, we have the observed frequencies showing how often people in different employment categories travel. To calculate expected frequencies, we use the formula row total times column total divided by n. This helped us to estimate what the frequency will be if there were no relationship between employment status and travel frequency. These values allow us to compare with the observed data and perform a chi-square test to see if there's a significant association. Now for step 2, before implementing the decision rule, we need to determine the test statistic for our chi-square test. The formula used is shown above. This compares the observed frequencies with the expected frequencies across all cells. As a result, the total of chi-square test or the test statistic is 1.046. Now, we need to calculate the degree of freedom. It is calculated using R-1 times C-1. In our case, with 2 rows and 2 columns, the degrees of freedom equal to 1. With a level of significance of 0.05, we now have all the components needed to proceed with hypothesis testing. This step is crucial for determining whether the opposite differences are statistically significant. In this final step, we apply the decision rule to determine whether to reject the null hypothesis or not. We compare the calculated chi-square statistic of 1.046 to the critical value of 3.841 at a 0.05 significance level with 1 degree of freedom. Since the test statistic is smaller than the critical value, we do not reject the null hypothesis. This shows that it is not enough statistical evidence to suggest a significant relationship between employment status and LRT travel frequency. This means that these two variables appears to be independent. Now, you may ask, how you confirm this? The trick is for this case, we can see that the test statistic is on the non-rejection area as it's smaller than the critical value.
For question 4B, we look at whether there is a difference in overall satisfaction between male and female passengers. Because we are working with ordinal data like Likert scale and 2 groups. We use the man with mu test where a non-parametric alternative to the t-test. Next is hypothesis for gender satisfaction. Null hypothesis, where male and female passengers have the same overall satisfaction. And alternative hypothesis, there is a difference in satisfaction between the 2 groups. Again, we tested this using a two-tail approach with a 0.05. Here's what we found. Male respondents, we got 40 people, and female respondents, we got 100 people. For U statistic, we got 1746.5. For Z-score, we got negative 1.1693. For p-value, 0.2423. Since the p-value is greater than 0.05, the result is not significant. So what does this mean? We failed to reject the null hypothesis. Based on the data, there isn't enough evidence to say that gender affects overall satisfaction with the LRT, while female passengers had slightly higher and more varied scores. The difference isn't statistically meaningful.
For question 4B, we ran a man-Whitney U test to compare median satisfaction between males and females. We calculated overall satisfaction by averaging scores from SS4 to PS3. Then, we ranked all scores and found the sum of ranks for both groups to calculate U1 and U2. From the output, we can see that U2 was smaller, so we use it to compute the Z statistic, which was 1.169, and the p-value was 0.2423. Since the p-value is above 0.05, we fail to reject the null hypothesis. So there's no significant difference in satisfaction between male and female passengers.
The Kruskal-Wallis test is a non-parametric statistical test used to determine if there are significant differences between the medians of 3 or more independent groups. In this test, we compare respondents' education levels with their satisfaction towards 2 key aspects of LRT service. First is safety and security, and the second is proper condition and maintenance of facilities such as elevators and escalators.
So we need to find a correlation between these two situations with their education background. So as you can see here, the hypotheses are quite similar. For the null hypothesis, it is identical, and for the alternative hypothesis, it is not identical. Compute the Kruskal-Wallis. Firstly, we use the function rank.avg in Excel to sort our data. Then we sum up each category of education's rank. After that, we computed the data into the H-test formula. Since we have 3 groups, our degree of freedoms is 3 minus 1 equals to 2. To obtain critical value, we refer to chi-square table using the df2 and alpha 0.05. So as you can see, it's actually the same process for situation 2. And also, you can see here, this is the Kruskal-Wallis H-test formula that I mentioned before. The H-test statistic is compared to a chi-square distribution with C-1 degrees of freedom, where C is the number of groups. After we computed the H-test and finding the critical value, we need to come to a decision whether to reject or accept the hypothesis. So if the calculated H value is greater than the critical value, the null hypothesis is rejected, suggesting significant differences between at least 2 of the groups. Okay, as you can see here, for the first situation, we got 0.7291. Okay, and for the second situation is 1.18. So we compare it to our critical value, which is 5.991, and both of the situations have lower value than critical value. So there is not enough sufficient evidence to reject that the population medians are all equal.
Alright, to sum it up, in this study, we explored the factors that influence passenger satisfaction with LRT services by applying a range of statistical methods. To ensure a well-rounded analysis, we used both parametric and non-parametric tests. One of the key findings was that there is a clear difference in how satisfied passengers feel about disabled-friendly features compared to elevator conditions. The data suggests that accessibility is more appreciated and possibly more consistently maintained. On the other hand, when we look at overall satisfaction between male and female passenger, there wasn't a significant difference. This was supported by both the independent t-test and the Mann-Whitney U-test. We also tested whether how often people use the LRT affect their view on timeliness. The result from the ANOVA showed that travel frequency doesn't make much of difference. However, we did find a significant link between employment status and how frequently people use the LRT based on the chi-square test of dependence. This makes sense as working individuals are more likely to rely on public transport regularly. Lastly, we used the Kruskal-Wallis test to see if education level affects satisfaction with safety and facility condition. The result showed no meaningful difference, indicating that people from different education backgrounds tend to view this aspect similarly. Overall, this analysis helped us identify which part of the LRT service matter most to passengers. This insight can be useful for service provider to improve areas that truly impact passengers' experience. That's all from us. Thank you.